This is the next one. Again, something called replacement, repeated replacement. Repeated replacement basically is useful, and these kind of questions are also asked. I'll give you an example of what is the situation in which this kind of formula has to be applied, and then I'll explain this formula. You are told that there is a solution. There is a solution of milk, say this has say 80% milk and the remaining 20% is water. What you are told is the volume of this solution is also given. You can assume that the volume of the solution is say 100 liters. What you are told is that 10 liters are removed from this solution. So now you have 90 liters left. And these 10 liters are replaced with water. They're not replaced with milk, they're replaced with water. And you are also told that, okay, this procedure is repeated 3 times. That is basically you are told that there is a 100-liter solution of milk which has 80% milk. This is given to you. 10 liters from the solution is replaced. First it is removed and then you are pouring pure water. Then again you are removing 10 liters of the solution. Again you are adding pure water. Again you are replacing 10 liters of the solution and adding pure water. Finally you are asked what is the volume of or what is the percentage of milk in the solution. In those kind of questions or in similar questions where this is the setup, you will have to use this particular formula. You will get the answer very quickly. What exactly does this formula say? In this particular case, what we are told is you need to know the initial volume of the solution. Let us assume that is V. You also need to know what is the small part which is being removed. In the earlier case, the volume is 100 liters, 10 liters is being removed and replaced. Suppose this is the original volume and you are replacing say X. You should also know what is the original concentration of milk. The original concentration of milk, let us assume, is C. Now, when this method or this process happens one time, the new concentration will be equal to C into V minus X divided by V. That is, in the earlier scenario, the original concentration was 80%. The original volume was 100 liters. And the volume that was removed is 10. So 100 minus 10 is 90. So if this procedure happens one time, the new concentration is 80% into 90 by 100. If this procedure repeats the second time, the new concentration will be C into V minus X whole square. If this process happens 3 times, it will be C into V minus X whole cube. If it happens n times, the new concentration will be C into V minus X whole to the power n. This is basically something you should remember. This also we have given over here. It is basically the same thing with different variables. If X% of the solution is replaced with another solution, the concentration of A will be 1 minus X by 100 into I, which is basically what we are essentially saying. Here they have given it as a percentage. There I have taken it as numbers. Again, if you are simplifying it, it will be just C into 1 minus X by V. That X by V is the percentage that is removed. And if this happens the second time, it will be the initial concentration into 1 minus X whole square. If it happens the third time, it is initial concentration into 1 minus X whole cube, and so on. This, I would say, is something that you should remember. Basically, it is very simple. The way I look at it is, if the initial concentration is 80%, what is the amount of the solution that is left? In the initial one that we thought about, 100 liters was there, 10 liters was removed. So what is left is 90. So I would just multiply it with 90 and divide it by the total volume, which is 100. And if this procedure happens multiple times, I will just raise it to n. What I look for is, this is basically whatever is left, whatever is not removed. And Nietzsche is basically the total volume. That is basically what I look at. I hope this was clear to you. So basically what we are told is that there is a container which contains a mixture of milk and water in an unknown ratio. So let us assume that there is some milk and there is some water. The ratio is not given to us. and 1/3 of the solution is drawn and replaced with pure milk. So 1/3 is removed and replaced with milk. Then we are told that again 1/3 is removed and replaced with pure water. So this process is again repeated, but this time 1/3 is removed and replaced with water. After these two operations, the container contains milk and water in the ratio of 1:2. So basically what I would say is there was one ratio initially of milk and water. Then one ratio comes after 1/3 is removed and replaced with milk. Then another ratio comes after 1/3 is removed and replaced with water. What we are now told is that after these two operations, the container contains milk and water in the ratio of 1:2. So now the ratio is 1:2. What we are asked to calculate is the concentration of milk in the original solution. We are asked to calculate this, what happened at the start. Now, before we go this, let me quickly remember and remind that formula so that we can solve it very quickly. Suppose we have a container. Suppose the fraction that is removed is say F. The initial concentration is say C. This is initial concentration of say milk, and milk is being replaced with water. The new concentration will be C into 1 minus F. If this happens again, where again the solution is removed and replaced with water, the concentration of milk becomes C into 1 minus F whole square. F is basically the fraction that is being removed. In this particular case, just before the last step, that is, before this is being removed and replaced with water, let us assume that the concentration of milk is say C. So, C into 1 minus 1 by 3 will be equal to, what is the final concentration of milk? Milk and water are in the ratio of 1:2. So, the concentration of milk becomes 1 by 3. So, C into 2 by 3 is equal to 1 by 3, or C is equal to 1 by 2. So, what it means is that after this happened, after 1/3 is removed and replaced with milk, the concentration of milk is 1 by 2. That is, milk is 1 by 2 and water is 1 by 2. But this is after 1/3 is removed and replaced with milk. Let us assume that the concentration of water is W before this. Remember that here it is being replaced with milk. Here we replaced it with water. In most questions, you are told that you remove the solution and you replace it with water, which is basically what happens on a day-to-day life. Like milk will get removed and replaced with water. Here we are told that 1/3 is removed and replaced with milk. So you should not forget that. So whatever replacement is happening, water is getting replaced. So let us assume that the concentration of water is W. So W into, what is the fraction that is being removed and replaced? 1 minus 1 by 3. What is the final fraction? It is 1 by 2. That is, W into 2 by 3 is equal to 1 by 2, or the value of W is equal to 3 by 4. What this would imply is that the fraction of water at the start is 3 by 4. Therefore, the fraction of milk at the start will be 1 by 4. What we are asked to calculate is the concentration of milk in the original solution, which will equal option A, which is 25%.